Hello.
Good evening, sir.
Yeah, good afternoon. So we'll do some more problems and advanced cases for YDSE. Uh, question one is this. So in a YDSE setup, light of wavelength lambda is equal to 5893 angstrom is being used. The interference pattern is obtained on a screen which is at a distance of capital D is 1 meter from the slit plane, from the slits. Now in the pattern, in the interference pattern, tenth bright fringe is located at a distance of 12 millimeter. Tenth bright fringe is at 12 mm from central maximum. Central maximum. Find small d, basically slit separation. This is what you have to find. So at a distance of 12 millimeter, you have the 10th bright fringe. Okay, right?
Yeah.
So how would you do this? You know the position of each bright fringe, right?
Yeah.
So you have y is equal to
And lambda,
n
capital D.
lambda capital D by small d, right?
Yeah.
And this n is 10, that
Yeah.
is the 10th bright fringe, right?
Yeah.
So, so notice that the central one is not counted. This one is said first, this is second, this is third, like that, right?
Yeah.
Central bright fringe, we know it is bright fringe, it is n is equal to 0 basically, right?
Yeah.
So then you just put 10, 5893 into 10 power minus 10 multiplied by 1 by d should be equal to 12 into 10 power minus 3, right?
Yeah.
And then from there you just directly find out d, correct?
Yeah.
Okay, so that is pretty straightforward. Then second one is this. Now two slits in YDSE have width in the ratio of 1:25. Determine the ratio of intensity at the maximum and the minimum of the interference pattern. Here slit width has been changed, right?
Yeah.
So slit width has been changed. That means what? Intensity of light from each slit is directly proportional to the slit width. Okay. So I have a wider slit and a narrower slit, and more light passes through here, right?
Yeah.
Less light passes through here. So if you have a different width of slits, then that just means it is not I naught and I naught. It is I naught and I dash, right?
Yeah.
So if I have two slits with the ratio of 1 is to 25, then I naught and 25 I naught. Okay.
Yeah.
This is the starting point. Now from here, you have to find out the ratio of intensity, maximum and minimum intensity on the screen. On the screen, what will be the ratio of maximum and minimum intensities? Try to figure that out.
We can use amplitude, right?
You can use amplitude. If the amplitude here is A naught, amplitude here should be 5 A naught, right?
Yeah.
So constructive interference, wherever it happens, it will be 6 A naught for maximum, right?
Yeah.
And 4 A naught for minimum, right?
Yeah.
So intensity would be 16 and 36, right?
Yeah.
E naught square and E naught square, right?
Yeah.
The ratio of maximum to minimum intensity would be 36 by 16, which is 9 by 4, right?
Yeah.
So that is how you figure out. Here the pattern will be such that it will be 9 by 4. So central point, the intensity should have been 36 E naught square, right?
Yeah.
Because central point there is no phase difference. This is a maximum, and then minima will happen, which will be 16 E naught square.
Yeah.
Okay. Then next one is this. In Young's experiment, interference bands are produced on a screen. Screen is at 1.5 meter from the two slits, from the slits, which are 0.15 mm apart, right? And
Yeah.
wavelength of light lambda is equal to 6,500 angstrom. Now, first thing is find fringe width. That should be a straightforward calculation. Second thing is change in fringe width. Fringe width. If the screen is taken away, screen is taken away by a further 50 centimeter. Pretty straightforward only. Fringe width, you know the formula for that.
Yeah.
Beta is equal to
Capital D lambda by small d.
2D, right? Fringe
Yeah.
width is the separation between consecutive bright fringes, right?
Yeah.
N lambda by D. Wait,
Yeah.
fringe width, am I saying correct thing or am I saying am I making a mistake? Oh, it is not 2D, it is single D only, right? Right? Because N plus 1 lambda D by D minus N lambda D by D, right?
Yeah.
So the fringe width is lambda D by D. So you
Yeah.
just put the values here, lambda, capital D, small d, and you'll get the answer, right?
Yeah.
And basically, again, what has happened? Your D has increased to 2 meter. now if the screen is taken further away, right?
Yeah.
Makes sense, right? Very easy.
Yeah.
Okay. Then this one in Young's double slit experiment, slits are 0.5 millimeter apart, 0.5 millimeter apart, and interference is observed at a distance of 100 centimeter from the slits. It is found that ninth bright fringe is at a distance of 8.835 mm from second dark fringe, right? Find lambda. Right, so you have to focus on the screen. There is a central maxima here, and then somewhere on top there will be a ninth bright, right?
Yeah.
Somewhere here there will be a second dark. This separation has been given to you, right?
Yeah.
So where is ninth bright fringe from this zero level?
At 9 lambda capital D by small d.
At 9 lambda capital D by small d. So that is your y1. And where is the second dark fringe?
3 lambda capital D by 2d.
So 3, because the first dark fringe is when it is just at beta by 2, right? Lambda d by 2d.
Yeah.
And second one will be at 3 by 2 beta, right?
Yeah.
Lambda d by d, right?
Yeah.
So the gap between them you calculate, and the gap between them is given. So after that, it's just putting the data in and solving it, right?
Yeah.
So these basic positions of all of this position of bright and dark and all should no longer be a problem, right?
Yeah.
Okay, fine. So now let's look at some of the changes or extensions to modifications to the YDSE setup. Modifications to YDSE setup, which might come in some problems for you. So the first situation is the screen, the slits are like this, the screen is like this, but the light that is coming is not parallel in this way, it is like this, right? It's at an
Yeah.
angle. So light is coming like this. And basically this angle is given to be theta, right? This
Yeah.
length is small d and this distance is capital D, right?
Yeah.
Now, due to this, how will you analyze your intensity at a point P or something, correct? Let's take 2 points. One is P1 and one is P2, right? One is below the central maxima point and one is above. So, in this case, uh, let's also analyze it at the C point. So, if you realize at C point, the distance after the slits is same, right? At the point C, the distance that light ray covers after the slits
Yeah.
equal. This is equal to this, right?
Yeah.
So no phase difference here, but extra distance is covered by the light to reach this, right?
Yeah.
So you will realize that total path difference would be this extra path that this right ray traveled, ray 1 over ray 2, right?
Yeah.
So this distance is clearly, this is d, this is theta, this is 90 minus theta, this is theta. So d sine theta, right?
Yeah.
Correct.
Yeah.
So the top ray, the ray 1, has covered extra distance of d sine theta. So path difference is equal to d sine theta, right? So
Yeah.
it has phase, extra phase, or phase difference would be 2 pi by lambda into d sine theta, right?
Yeah.
At the point C, correct?
Yeah.
So normally at the point C, the phase difference used to be 0. Now there is something, right?
Yeah.
Intensity at C will become 4 I naught cos square phi by 2. And this is called phi, this angle, right?
Yeah.
So this is a non-maximum intensity. It is some interference intensity which is between 0 to 4 I naught, right?
Yeah.
Now let's think about what happens at point P1, right?
Yeah.
Correct.
Yeah.
You understood this part, right?
Yeah.
So what do you think should happen at point P1? Now ray will come from here to here and from here to here, right?
Yeah.
And let's say P1 is at P1's position here is some alpha angle here, right?
Yeah.
Correct.
Yeah.
So normally if it was parallel rays, right? If it was parallel rays coming, then you would have just said that, okay, this path is longer, right?
Yeah.
And this path is smaller. So there is a phase difference which is equal to this extra path, right? This much.
Yeah.
And this extra path would have been d sine alpha, right?
Yeah.
Correct.
Yeah.
So the ray 2, this second one would have had extra phase of d sine alpha, and that is how you would have calculated intensity. Same process like this, right?
Yeah.
But in this case, the first ray had already covered extra of d sine theta, right?
Yeah.
Now, first ray is covering after this some small distance, and second ray is covering greater distance, right?
Yeah.
So you have to take into account both the path differences, right?
Yeah.
So technically, you will say that, okay, here this was longer, here this is longer. So effectively, you can say that d sine theta minus d sine alpha is the path difference, right?
Yeah.
You understand why minus, right?
Yeah.
Ultimately, it's just about path difference. Once you have this, you will just convert it to phase difference and angle phi and then do it the same way, right?
Yeah.
On the other hand, if you're coming to point 2, here, the first ray is again traveling more distance than the second ray, right?
Yeah.
So this time path difference would be what?
D
Added,
sine
right?
theta plus D
Hmm.
sine alpha.
Plus d sine alpha. And again, after that, you do 2 pi by gamma, get the phi and get the intensity, right?
Yeah.
You understand, no?
Yeah.
Uh, okay. And remember that in this second section, you can say sine theta is similar to tan theta and stuff. You can write it as y by capital D and things like that, right?
Yeah.
Just like we did in the normal setup.
Yeah.
Okay. Then uh, what about if you have to calculate path difference between two parallel waves when one wave is traveling through some denser medium for some distance, right?
Yeah.
We briefly discussed that in the previous class. We said, okay, if one ray is traveling through some denser medium, like let's say a thickness, some thickness W, right? And or I'll just set it up like this. Uh, let's say this is one slit, and we have to calculate the situation at this point, and there is a slab like this of width t and mu refractive index, right?
Yeah.
So now, because of the presence of this, there is an extra optical path here, right?
Yeah.
So whenever light passes through a medium of thickness t and refractive index mu, the actual path may be t thickness, but the optical path is mu t, right?
Yeah.
And corresponding to this, light would have passed through air here, right?
Yeah.
So it has only passed through t because air's mu is 1, right?
Yeah.
So this has given this path an extra phase or extra path length of mu minus 1 into t, right?
Yeah.
Like some slight extra path length of mu minus 1 into t has been added to S1p, right?
Yeah.
Correct.
Yeah.
But normally, if nothing was there, this S2p is a longer path, right?
Yeah.
So S2p was longer by the d sine theta, where t is this angle is theta, right?
Yeah.
So normally, if nothing was there, you would have written S2p minus S1p is equal to d sine theta, right?
Yeah.
But now, since there is an extra path in S1p, the effective path difference is becoming what? You will subtract it or add it.
Subtracted.
D sine theta minus this, right?
Yeah.
Because S1p has become slightly longer, right? By this much amount.
Yeah.
So this becomes your effective path difference. Again, sine theta can be written as tan theta and dy by capital D minus mu minus 1t, right?
Yeah.
And that is your path difference. Multiply this by 2 pi by gamma to get your phi phase angle difference. And then after that, you can do the stuff. Right?
Yeah.
After that, you know what the intensity will be. Intensity at this point is always 4 I naught cos square phi by 2.
Yeah.
As long as both the slits had same I naught and I naught, right?
Yeah.
Now, remember that there are so many things you can change, right? You can change the slit width also for one of them, correct?
Yeah.
If you change the slit width, this formula will not work, right?
Yeah.
You will have to do it properly, like amplitude, what is the maxima and stuff, right?
Yeah.
Basically, the formula is I1 square plus I2 square plus, uh, 1 second. The formula for resultant intensity is I1 plus I2 plus 2 root I1 I2 cos phi, right?
Yeah.
Correct.
Yeah.
Because I1 is K A1 square and K A2 square plus, you understand this is the same amplitude formula except written in terms of intensities,
Yeah.
right? If I1 and
Yeah.
I2 are both I naught, then it becomes 2I plus 2I cos phi, which is this, correct?
Yeah.
And phi has been calculated by this method, right?
Yeah.
Okay. Uh, then what happens if you immerse the whole YDSE setup in some liquid? What will be the effect of immersing the entire setup in a liquid of refractive index mu, right? Now, remember that if you immerse the whole thing in the liquid, then obviously there is no phase change difference, right?
Yeah.
Because both the slits are facing the same liquid, right?
Yeah.
So nothing will change in terms of location of the central maxima and stuff. Like central maxima will still be at the center point and so on, right?
Yeah.
However, what is the quantity in the YDSE experiment that depends on wavelength? If you see, fringe width depends on wavelength, right?
Yeah.
And obviously also position of bright fringe and dark fringe also depends on wavelength, right?
Yeah.
N lambda d by d and all, right?
Yeah.
So the only thing that changes is when light passes through a medium of mu refractive index, your effective wavelength is lambda by mu, right?
Yeah.
So what will happen? This fringe width will become beta by mu, right?
Yeah.
So it's just that normally in air, the central maximum would have been here, the first bright fringe would have been here, first bright fringe would have been here, and now it will be closer, right?
Yeah.
Everything will be closer spaced, right?
Yeah.
But nothing else will change because the whole thing was inserted in the liquid, right?
Yeah.
So fringe width will reduce, but nothing else will change. Makes sense?
Yeah.
Okay, let's do a couple of questions. Uh, so suppose there are two coherent sources, S1 and S2, which produce waves in the same phase, and are placed on the y-axis, at 0, 2D and 0D. So basically, you have y-axis here. One source is S2 and one source is S1, and this is 0 comma D and this is 0 comma 2D, right?
Yeah.
A detector is placed at the origin. This is origin, and there is a detector here D, which can move along the x-axis. Detector can move this way, right?
Yeah.
So you have to find the number of maxima recorded by the detector as it moves from x is equal to 0 to x is equal to infinity. Okay. Wavelength of light is lambda is equal to 6200 angstrom, and separation between the sources or D value is 0.34 millimeter, right?
Yeah.
Okay. So originally detector was here, right?
Yeah.
So, and then it starts moving this way. And so you notice that initially detector was seeing that clearly the rays are having a path difference, right?
Yeah.
The path difference initially is small d only, right?
Yeah.
So path difference is small d. Difference is small d initially. So that is 3.4 So what is the phase difference initially? Phase difference initially would be 2 pi by lambda into d, right?
Yeah.
Correct.
Yeah.
Uh, okay. And as you move this way, right, your paths start changing. Path difference you have to sort of measure, right?
Yeah.
This and this. So, I mean, you can technically find out the length of this and the length of this at an arbitrary x, right?
Yeah.
And the difference between them, right?
Yeah.
So at any point, if someone asks, you can find out what is the path difference and you can sort of try to make sense of like what will be the maxima or minima situation, right?
Yeah.
But since you have to count how many maxima and all, you have to think about the situation where this x tends to infinity, right?
Yeah.
In that situation, what is the path difference, right?
Yeah.
X tends to infinity. So, okay, in that case, so what is an expression for the path difference? You can say the path difference expression here. What is the path here? Root over x square plus d square, right?
Yeah.
And here, what is this path? Root over x square plus 4d square, right?
Yeah.
So root over x square plus 4d square minus root over x square plus d square is the general expression for path difference, right?
Yeah.
Correct. And you
Yeah.
have to estimate what this will be when x tends to infinity, right?
Yeah.
Okay. So in order to do that, let's find out this quantity or mathematically try to analyze this quantity, and path difference is this thing, and if you multiply by the conjugate you will get on top 4d square minus d square, so 3d square by root over x square plus 4d square plus root over x square plus d square, right?
Yeah.
Hmm. Okay. So clearly it seems like this tends to zero, right?
Yeah.
Right.
Yeah.
So there will be a maxima at that location, no, as x tends to infinity, right?
Yeah.
That will be the last maximum.
Yeah.
So this point, when path difference was d, uh, d is how many times of wavelength is d, right? You understand what I'm saying? Like d can be written as 34.34 millimeters. So 3.4 into 10 power minus 4 meter, right?
Yeah.
This is what multiple of the wavelength, right? Because like if path difference was, let's say 3 lambda here, right?
Yeah.
And then it became 0 here, right? Then you
Yeah.
have one maxima here, one maxima at 2 lambda, one maxima at lambda, and one maxima at 0, right?
Yeah.
So if path difference here, if we know the number 3, this divided by 6200 into 10 power minus 10 meter, right?
Yeah.
That should give us a value of what is the actual path difference. D stands for what lambda, right?
Yeah.
You understand what I'm saying?
Yeah.
What multiple of lambda is it, right? So this will be, if you calculate it, this turns out to be 548.4 lambda, right?
Yeah.
So that means that here it was 548.4 lambda path difference. So somewhere down the line, you notice that path differences are decreasing as you go this side, right?
Yeah.
You would have a 548 lambda somewhere here.
Yeah.
So that would be your maxima, right?
Yeah.
And then after that, you would have a 547, 546, and so on, right?
Yeah.
Till finally you go to the zero lambda position, right?
Yeah.
So therefore, if you count all the maximas, you'll get 548, 547, so on till zero. So you'll get 549 maximas, right?
Yeah.
Counting the last maxima at infinity. If you don't count that one, you will get 548, right?
Yeah.
Are you understanding?
Yeah.
Okay. Then what other changes can we make to this? We have already discussed what happens when you change the slit width. It just changes intensity, right?
Yeah.
So changing slit width changes intensity and you have to measure accordingly, right?
Yeah.
Then what happens if we okay, I think that's about it. I don't have anything more that I can add to this. I think whatever we have discussed so far should more or less cover like all the types of cases you will encounter. Definitely in JEE mains you cannot encounter anything more. Okay. So for now, this should be enough. You can try more questions and get back to me if there is any particular problem. Right.
Yeah. Okay.
What we'll do is we'll solve some of the questions or doubts that you had shared earlier. Right.
Yeah.
1 second. There were some maths doubts. Uh, Number of irrational terms in the expansion of this. Let's do the maths ones first. Number of irrational terms in expansion of 3 power half plus 5 power 1 by 3 power 60. Right?
Yeah.
So, okay. This is fairly easy, I think, because anytime any power of half is left, it will be irrational, right? And similarly, anytime any power of 1 by 3 is left, it will be irrational, correct?
Yeah.
So if you write the expansion here, it is NC0, 3 power half power 60. That's it. Then NC1, 3 power half power 59, 5 power 1 by 3 power 1, and so on, right?
Yeah.
So you have to realize that the terms will be rational when, let's take a general term, NCR 3 power half power 60 minus R and 5 power 1 by 3 power R, right?
Yeah.
So this rth term is NCR 3 power 30 minus R by 2 and 5 power R by 3, right?
Yeah.
So whenever R is a multiple of 6, right?
Yeah.
Half and 1 by 3, whenever it's multiple of 6, what will happen? That time both the fractions will be fine, right?
Yeah. So it will be rational.
Correct. That will be rational, right?
Yeah.
So if you think R is 0, 0 is a multiple of 6, 0 is a multiple of everything. 0, 6, 12, 18, and so on till 60, right?
Yeah.
So there are 11 terms, right? Here.
Yeah.
Total number of terms are how many in the series? 61.
Yeah.
So 11 terms when everything becomes rational. So 50 terms when they are irrational, right?
Yeah.
So look at the general term and see when it doesn't become, like you have to make R divisible by 2 also and divisible by 3 also, right? Correct.
Yeah.
Then only you can not have roots. So R should be a multiple of 6 and therefore these are the values of R at which it will be rational, right?
Yeah.
That is this one. Then what other ones are there? Then the next one is this limit one. Okay. If limit x tends to root a, b minus cos x square minus a by x square minus a sine c x square minus a is equal to L, non-zero, finite, a is greater than 0, and value of L plus b plus c, right?
Yeah.
And L plus b plus c is what? Okay, so x tends to root a, this will become a minus a, so 0, b minus 1 by
0.
0, 0, right?
Yeah.
So that cannot be finite unless b is 1, right?
Yeah.
So first of all, from there only we realize that b has to be 1,
Yeah.
because then only you will have 0 by 0 form, right?
Yeah.
Okay. Now let's say b is 1. So 1 minus cos of x square minus a by sine x square minus a into sine of c x square minus a, right? This
Yeah.
1 minus cos of x square minus a can be written as 2 sine square x square minus a by 2, right?
Yeah.
That is your half angle formula, right?
Yeah.
Divided by, we have x square minus a and sine of c x square minus a, right?
Yeah.
So this 2 I can bring here, right?
Yeah.
Correct. And this part is tending to 1, right?
Yeah.
Because you have a minus a 0, and no, this part is not tending to 1. You have to make this is sine square, right? So you need one more square here, right?
Yeah.
You understand?
Yeah.
So just write it as a square here, then you have to multiply by x square minus a by 2, right?
Yeah.
Then this part vanishes,
Yeah.
0 by 0, right?
Yeah.
And then this limit also has to work out, correct?
Yeah.
So, okay. So, fine. So, I need, for this to work out, I need, this is becoming CA minus A, right?
Yeah.
And this is 0, right?
Yeah.
So, C should be, and because the limit is non-zero, if it was CA minus A, some normal non-zero thing, and top was 0, limit would have been 0, right?
Yeah.
Are you understanding what I'm saying?
Yeah.
Because it has to be non-zero, this C should be 1, right?
Yeah.
Only if C is 1, you will have 0 by 0 types, right?
Yeah.
Okay. And then if C is 1, I will just put this as x square minus a by 2 2 times sine of x square minus a, right?
Yeah.
So the limit will come out to be now half, right?
Yeah.
So L is half, B is 1, C is 1, right?
Yeah.
The answer will be 2.5.
Yeah.
So basically, because it has to be non-zero and finite, the first thing we said was for it, because it had to be finite, we have to make it 0 by 0 form. That gave us B is 1, right?
Yeah.
Once we did B is equal to 1 part, we did sin x by x limit here. And since there was no square here, I had to multiply, make it a square here and multiply by the same thing here, right?
Yeah.
And then this disappeared. Once this disappeared, I want this to be a non-zero finite limit. So if we didn't know the value of C, or if C was not 1, right? Then what would
Yeah.
happen? Top part is 0 and this part is not 0, right?
Yeah.
Then the limit would have been 0, right?
Yeah.
So C has to be 1 because then it becomes 0 by 0 form, right?
Yeah.
If C is 1, then you get this limit, which is very easy. Answer is half, right?
Yeah.
So the overall thing is coming out to be 2.5. Okay. Then this one, question 75. Value of summation 100 r is equal to 3 r by r minus 2 factorial plus r minus 1 factorial plus r factorial. Okay, value of this summation is being asked. Starts from 3. So basically you start by 3 by 1 factorial plus 2 factorial plus 3 factorial plus 4 by, you get 2 factorial plus
3 factorial
3
plus 4
factorial
factorial.
plus 4 factorial and so on. And so on, you go up to 100 by, you have 98 factorial plus 99 factorial plus 100 factorial, right?
Yeah.
Okay, so clearly we'll have to do some simplification here because otherwise it will be too long. So this general term we have to simplify in certain ways. So let's think about it. What is the value of r minus 2 plus r factorial? It is r factorial is r into r minus 1 into r minus 2 factorial, right?
Yeah.
So if you add r minus 2 factorial to it, you will get r minus 2 factorial common, r into r minus 1 plus 1, right?
Yeah.
So this becomes r minus 2 factorial r square minus r plus 1, right?
Yeah.
Correct.
Yeah.
And I have to add further r minus 1 factorial to it, which is basically r minus 1 multiplied by r minus 2 factorial, right?
Yeah.
Add that to this, you can write it as r minus 2 factorial common. You have r square minus r plus 1 plus r minus 1, right?
Yeah.
Makes sense.
Yeah.
So this cancels everything. You have denominator is r square into r minus 2 factorial, right?
Yeah.
And top part is r, right?
Yeah.
So this cancels, it becomes r into this, right?
Yeah.
Okay. So r square into r minus 2 factorial. Okay. So you have summation is actually r by r square into r minus 2 factorial from 3 to 100, which can be written as 3 to 100 1 by r into r minus 2 factorial, right?
Yeah.
Now the top part, if you put a half here and a 2 here, right? The top part can be written as r minus 2, right?
Yeah.
Makes sense.
Yeah.
I have put a half outside and 3 to 100, right?
Yeah.
And this can split now as 1 by r minus 2 factorial minus r minus 2 will cancel, and this will become 1 by r into r minus 3 factorial, right?
Yeah.
Correct.
Yeah.
And half summation 3 to 100, right?
Yeah.
This is the same thing as the original summation. So hopefully when we write some terms, we'll start seeing some patterns, right?
Yeah.
Because we have expressed this as a difference of two things, right?
Yeah.
So let's write some terms. The first term is half. When r is 3, what is it? 1 by 1 factorial minus 1 by 3 into
3.
0 factorial, right?
Yeah.
Then next one is what? Half into 1 by 2 factorial minus 1 by 2 into, no, r is
2.
4. So 4 into 1
1.
factorial, right?
Yeah.
And then we have 1 by 5, no, 1 by 3 factorial minus 1 by 5 into 2 factorial. Okay, right now I'm not seeing any pattern. We possibly need a, hmm, wait, this is r minus 2 factorial, right? So,
For the initial part, what if instead of making the numerator 1 into 2, we multiply top and bottom by r minus 1?
here,
Yeah.
1 second. Top and bottom by r minus 1. Yeah, that is probably better. So, not this. We multiply by r minus 1, you get r minus 1 by r factorial, right?
Yeah, and then we can split it.
Then it is much better. Right? Only r minus 1 was missing here.
Yeah.
Now you get 1 by r minus 1 factorial. Now it is done. Right?
Yeah.
Now it will cancel nicely. Right?
Yeah.
Because these are successive terms, so there's no issue. You will cancel it off nicely and you will get the sum. Right?
Yeah.
So the main point was to get to this point, to here,
Yeah.
which was
Yeah.
basically a little bit of simplification. Simplification by noticing that you can start off with the first and third term and express the second term as r minus 2 factorial later, right?
Yeah.
Once you do that, you will get to here, and then the best way is to multiply by r minus 1 up and down, right?
Yeah.
Okay. Then next one is this integral x plus 2 dx by square plus 3x plus 3 root over x plus 1. Okay. Uh, Fine. This is some standard form here. Like we have to figure out a way to simplify this. Let's just take the most obvious thing. X plus 1 is equal to t square, right?
Yeah.
So that will mean that dx is equal to 2t dt, right?
Yeah.
And the top part, x plus 2 is t square plus 1, dx is 2t dt, and instead of x, this part can be written as, so x is t square minus 1. So x square is t square minus 1 whole square plus 3 times x plus 1, which is t square, right?
Yeah.
And this part becomes t, so this cancels this. Where 2 times t square plus 1 dt divided by t square minus 1 whole square plus 3t square, right?
Yeah.
Okay. So this denominator is t power 4 minus 2t square plus 1 plus 3t square. So it is just t power 4 plus t square plus 1, right?
Yeah.
So that is nice. 2 times integral t square plus 1 dt by t power 4 plus t square plus 1, right?
Yeah.
Now dividing up and down by t square, you'll get 1 by t square plus 1 on top dt, and here you'll get t square plus 1 by t square, right?
Yeah.
And then you take t minus 1 by t as your u, because differentiation of this will be 1 plus 1 by t square dt, right?
Yeah.
And this part can be written in terms of u, right?
Yeah.
You understand, no? So
Yeah.
you'll get du on top, and you'll get t square plus 1 by t square will be u square plus 2, right?
Yeah.
This is u square plus 3, right?
Yeah.
So the integral will be 2 by root 3 tan inverse u by root 3, something like this, right?
Yeah.
And then you have to put back, t you have to put back and stuff.
Yeah.
So we started off with this. The most obvious substitution was this, to remove the root. Then we got some stuff here, and then we noticed that this became this, right?
Yeah.
Once you get till here, then after that, it is obvious that you have to divide by t square, because this is a this looks like no, dividing by t square just solves it, right?
Yeah.
You have to take t minus 1 by t as u. Obviously, all of this will come with a little bit of practice. Like, it's not like it seems obvious to me, but you have to have seen such integrals before to be able to be sure. So, but this is not very difficult once you have a little bit of experience. Till where did you do it? What did you do?
I did the first substitution.
You
I
got till here.
Yeah, I got it till there.
Till here you got this one.
Yeah, I did not divide it by t square.
So uh, dividing by x square and dividing by t square is a common thing. You should check that always. If there is high powers, 4, 2, 1 and all, dividing should reduce the integral and make it look nicer. And also if there is 1 plus t square on top or 1 minus t square on top, right? Dividing
Yeah.
by t square always many times will work, because even if it was 1 minus t square on top, I would have gotten 1 by t square minus 1, right?
Yeah.
Then I would have taken t plus 1 by t as u,
Yeah.
right? This is a common substitution, t minus 1 by t or t plus 1 by t as u, which will give you either 1 by t square plus 1 or 1 by t square minus 1 on top, right?
Yeah.
Okay.
I had one more doubt from integration.
Hmm.
I have not sent it actually. I just found the question yesterday. Should I dictate it?
Okay.
It was x square divided by 2 plus 3x square.
X square divided by
2 plus 3x square. The denominator whole square dx. That's all.
this.
Yeah.
Okay. Fine. So first, maybe expand the denominator. It is 9x power 4 plus 2 into 2, 4 into 3, 12x squared plus 4. And on top you have x squared dx, right?
Yeah.
Okay. Dividing by x square, you'll get integral dx by 9x square plus 12 plus 4 by x square. Okay. That won't work. We want some x cube as t. We want some x cube substitution somehow. So there's no x cube and all here. This is the integral. Hmm. 2 plus 3x square. 2 plus 3x square. If we take this as t, we get 6x dx, right? Dt. Okay, fine, we'll do that only. We have 2 plus 3x square is t. You have x square dx on top. So x into x dx. So x into dt by 6, right?
Yeah.
And here you have t square. X you have to write as t minus 2 by 3 root, right? Correct.
Yeah.
So it is like 1 by t square root of t minus 2 by root 3. This comes out dt. This is the integral, which is not simple. Hmm. This is again not very simple, but maybe we can try something. T minus 2 is u square, let's do, right?
Yeah.
That will not help, I think, but I'm just trying. dt is becoming 2u du, and t is equal to u square plus 2. You'll get the same thing as before. Won't help. X square by 2 plus 3x square. So you're sure this is the question?
Yeah.
Where is it found? Where was this question?
Teacher had a worksheet, so she gave it to us.
Which teacher?
School.
School teacher gave this question. Okay.
It was supposed to be a 2-marker for boards.
It was supposed to be a
2-marker question for boards.
yeah, right. Okay. I mean, then obviously there is a mistake in the question because this cannot be a 2-marker. It's not easy to integrate. Like this will not come in JE advanced also because there is a mistake in the question. That is what I'm sensing because there is no way that I can proceed. There's no standard method directly works.
Yeah,
If
like
you
some people from class were trying to substitute x as root 2 by 3 tan theta to get rid of the 3x square and just make it in terms of tan theta, but I don't know if that worked.
you can try such things, but x has root 2 by 3 root 3 tan theta. That will make it x square will become 2 by 3 tan square theta. 2 by 3 tan square theta. That will multiply 3x square will become 2 tan square theta. Okay, that's fine. So you'll get 2 plus 3x square will be 2 plus 2 tan square theta, so 2 sec square theta. So you'll have 4 sec power 4 theta in the denominator. On top, you will have 2 by 3 tan square theta multiplied by root 2 by root 3 sec square theta d theta by 4 sec power 4 theta. So 2 by 3 root 2 by root 3 4 comes out. You have tan square theta by sec square theta d theta. Still, it will not be easy. Sine by cos square. Oh wait, it is tan square by sec square is easy, I think. Because it will become sine square by cos square into sec square. So sine square theta, right?
Yeah.
Then this is okay, this is over. But obviously, this is a really horrible question. It's like why would you make a question which has you have to substitute this? Like this is like if you only know trigonometric substitutions, that is the thing that you'll do. But like the question doesn't suggest in any way that you should try trigonometric substitutions here. And this trigonometric substitution is also not very obvious. To remove the roots, yeah, makes sense. But yeah, I mean, it's fine. But you will not get this as a 2 marker in boards. So this is a horrible question.
Yeah, but like we got it using trigonometry, like the people who got it,
Hmm.
the answer key was not using any of the trigonometry as well. It was like a very simple algebraic answer key.
So finally you can convert back.
Yeah, it was something like 1 by 7 into x cube minus 1 to the power 7 by 3 plus 1 by 4 into x cube minus 1 to the power 4 by 3 plus c. So
Okay. 1 x cube minus. Okay. If the answer key is not having any trigonometric stuff, then that means they're doing partial fractions here. Can I? Can you write this as sum of two fractions? Where I don't think you should worry about this question. Just ignore it. It's fine.
yeah,
Like obviously, there's one solution by a trigonometric substitution. You don't need to worry about other solutions here. Like it's unlikely that you will get this as a question in the boards. And
yeah,
this is not a question that is suitable for your multiple choice also, like, because there is no standard technique that is obviously apparent. Like maybe you can try some partial fractions. You will take denominators like this and stuff, but it is too long to try that also. Nobody
yeah,
can try that in an exam. Like you should ignore such questions. If you're stuck on some weird integral like this, like you can spend some time on it, but don't like spend too much time on it. It's a waste of time. So revise other things, do other things with your time. Okay. Anyway, decide on the stuff that you want to discuss in the next few classes. Like you are doing the NTA papers, right?
Yeah.
Go through the papers as fast as you can, as many as you can. And if you have doubts and all, you can decide and let me know what topics you want to discuss further, right?
Yeah.
Okay. I'll see you tomorrow then.
Thank you.
Bye.